So in maths, there's something that's known as the order of operations. One of the acronyms that I'll be referring to is BEDMAS for it. There are other acronyms to help you with this. However, the step-by-step is going to be absolutely identical no matter what acronym that they are using. However, it's really important to first of all understand the importance of why we have an order of operations to begin with before we look at how we use them. So let's consider this problem. I want you to pause this video for a moment and have a go at this problem. See if you can solve it. This is one that I got off of Facebook and I was tagged in by a friend of mine to help support his answer, is what he wanted as a maths teacher. So pause this video for a moment and then we'll continue. So I hope you've got a solution now. And I want to look at the different ways that you can think about this problem and the different reasoning behind everyone's argument that I'm seeing on the internet. All right, there might be some other solutions I might not cover, but we'll try and cover as many of them as I can. So some people might look at this problem and go, well, let's just work this out left to right, 5 subtract 5, and I'm going to use, let's use blue rather than red. I'm in a blue mood rather than a red mood. Let's do 5 subtract 5 first. I'm going to use working out that I absolutely hate to exemplify a problem later on. All right, but 5 subtract 5 is going to be 0. Our solution to that, we've got to multiply by 5 next. So 0 times 5 is going to be 0. And then we've got to add 5. So 0 plus 5 is equal to 5. And there's one potential solution that people are getting. Okay, and they've got a fair argument for that solution. Okay, some people might sit there and go, hey, I know about the order of operations. I know about BEDMAS. It says to do multiplication first. Okay, so it means that we've got to do this 5 times 5, which is 25. All right, and then it says that we should do addition. A is next. Okay, so addition. So 25 plus our 5, which is 30. Okay. And then we've got to subtract that away from our 5. Okay, so 5 subtract 30 will equal negative 25. All right. Some people will do a very similar process. Some people will look at it and go, well, let's just 5 times 5 is equal to 25. Okay, we need to do addition next. Okay, so that's 25, add 5. Okay, that's going to be 30. All right, and then we need to subtract our 5. So that's going to be 30, subtract our 5. That's our subtraction. All right, and that's going to be 25. All right, another solution. Okay. Some people sort of look at this and go, okay, order of operations again. Let's do multiplication first. So 5 times 5 is 25. All right, let's go 5 subtract 25 is going to be negative 20. And then let's add 5 to it. So negative 20, add 5 will be negative 15. Another solution. Let's think about another way. All right, some people might go, all right, so we can start to see a pattern here. This 5 times 5. All right, so I've seen a lot of these different answers and I could see what their thinking was in each of them. So I've gone 5 times 5 is 25. Great. Okay. So 25, subtract 5 is going to be 20. Okay. But then we need to add 5 to this again. So 20 plus 5 is equal to 25. Interesting. I got the same solution as I got back earlier, but in a different way. I wonder if that means it's correct. But what you're already seeing, and I might have missed some solutions here that I've seen on the internet. There are just a few that I did see people's answers, and people are super passionate about their answer. They would argue their answer to the nth degree, and there's some reasoning to it. You can see I've shown some reasoning to every single solution, but there's a problem here. And you can see the problem. It becomes really obvious to us. We've got so many different arguments and so many different solutions for the same problem. We can't have that in mathematics. We need a solution. We need one solution here to this problem. So this is the reason why we have an order of operations. And I'm going to try and step through some of, I guess, the issues and reasonings to different people's arguments here as we work through the solution. So what is the order of operations? Well, we've got an acronym to help us remember it, and I've got that to the right here, where the B is brackets, E is exponents, D is division, M is multiplication, A is addition, S is subtraction. And I've got it color-coded in this way for a reason. That reason is because I want you to consider D and M not as the order, but I want you to consider them on the same level. And the same applies with addition and subtraction. I want you to consider addition and subtraction on the same level. The order between the A and the S does not matter. The D and the M does not matter to an extent. I'll explain that soon. Okay? So, what is the order of operations? So, the first thing is we perform anything within brackets first. Having said that, we need to perform the order of operations inside the brackets as well, but we perform anything within the brackets first. The second thing we need to do is calculate anything involving exponents, indices, same sort of thing. All right? The third thing, and this is the reason why I want to consider them on the same level, the order does matter, but starting from left, we do all divisions and multiplications as you come to them. We don't do division before we do multiplication. We do it left to right as we come to them. And the same thing happens for additions and subtractions. We don't do addition before subtraction necessarily. We do them as we come to them. So let's look at our original problem then with this in mind. Does our original problem have brackets? No. So we skip step 1. Our original problem doesn't have exponents, so we skip step 2. But we do have multiplication. We don't have any division to worry about, but we do have multiplication. So the first step that we need to do is the multiplication. And I'm going to show the working out how I would show working out and how I recommend everyone shows working out. So we need to do the 5 subtraction. We need the 5 times 5, which is 25. And we need to add 5. Now, that's all divisions and multiplications dealt with in the problem. Step 4. So we need to restart from the left and perform all additions and subtractions as we come to them. Okay. So 5 subtract 25. Well, that's negative 20. But we've still got our addition. Negative 20 add 5 is negative 15. And negative 15 is the correct solution to this problem. Now, one of our solutions did have negative 15. However, some of them did not. Even though some of them did follow an order of operations. So let's kind of explain it here. The first one, the solving from left to right. 5 subtract 5, multiply by 5. Clearly, we didn't follow an order of operations, and that's the reason why we arrived to a different solution. Okay? The second process, we arrived to a negative 25. We did the 5 times 5 first and got to 25. We then added 5. So what we did was we treated addition on a higher level than subtraction. And that's the reason why we arrived to a different solution. The third example here, we did the addition again before we did subtraction. But we arrived to a different solution again. And we've got to look at, well, how did that happen? Well, what actually happened is instead of doing 5 subtract 30, we did 30 subtract 5. And I often see this as a problem with people's working out. When they're working out like this, they sometimes mess the order up of which we needed to do this subtraction in. This was clearly 5 subtract a number, not the number subtract 5. But people have gotten the solution and then subtracted 5 from it and arrived to 25. This one here, we arrived to a negative 15. We actually did the same things we did before, but just in a different working out, the working out I don't prefer. But this one here, what's interesting is we followed the correct step by step, but the same problem occurs here. We got to the subtraction step and we grabbed the number from here and mixed the order again. So some people were arriving to this positive 25 in a different way, but it was because they mixed the order of the subtraction again. And the order matters in that regards. So there's some reasoning, I guess, to why I suggest showing the working out in the way that it's done. But it's more to point out the reasons to the importance of the order of operations to begin with. And I think that is the most vital thing to understand, the order of operations does matter. Okay? And that's the reason why we have them. Now, I'm going to make this a two-part sort of episode. So, well, not episode, but thing. So the next one, we will look at applying the order of operations and some of the things that we need to be keeping in mind. And we'll also look at problems that have brackets and have exponents with them.